Hey guys, we're going to learn today about special right triangle shortcuts. There's two of them all together. So the first one's going to be a 45, 45, 90 special right triangle. So you need to first make sure that you're looking at an isosceles right triangle before you attempt to use this rule. If you do not know for a certain fact that you do have an isosceles right triangle, then you cannot apply this rule. So please know that you cannot assume anything. So showing you first, where does the rule come from? We are talking about triangles, but the rule does stem from a square. But we want to go ahead first and take a look at a square where we know that all of our sides are going to be congruent, and we have 4 right angles. From there, if we take and draw in a diagonal into our square, we know that then we'll have an isosceles right triangle, where we know that this will be a 45-degree angle. Know that we have a 90-degree angle down here, 45-degree angle here. So again, 45, 45, 90 right triangle. This rule stems from the fact that those are definitely the angles of the triangle in question. So what's the rule? The rule tells us that side lengths are going to be the same. You can see that. We do Pythagorean theorem a whole bunch of times with a whole bunch of different variations. We figure out that the hypotenuse is actually that exact length multiplied by the square root of 2. So let's take a look at some of our examples. In example 1, we can say that our side, I'll say, have a length of 3. So you can pause the video and try the problems yourself. When you're ready, you can go ahead and fast forward. But if this side length has a length of 3, this side also has a length of 3. And according to our rule, our hypotenuse is going to be 3 times the square root of 2. We scooch down to another example, show you a couple of different variations. We switch down to this example. Let's say this time I do the hypotenuse, and we can say that it has a length of 4 times the square root of 2. Well, since our hypotenuse is our leg times the square root of 2, that means that our leg has to have a length of 4 units each. Let's look at 2 more examples for this little section here. Let's say that I give you your legs now. So let's say I throw a radical in there. So let's say that this leg here has a length of 5 times the square root of 3. Well, this leg is also going to have that exact same length. But then we have to do a little bit of math to figure out what the hypotenuse is. We know that the hypotenuse has to be the leg multiplied by the square root of 2. Well, we just went over operations of radicals. So if we multiply the 2 numbers out front, we get 5. Then multiply the 2 radicands together, we get 6. So therefore, our hypotenuse is going to have a length of 5 times the square root of 6. So do one more type of example here in example 4. And this time I'm going to give you a hypotenuse. Let's say that's just a regular old integer. So let's say it's 7. Well, to get to our legs, we know that the hypotenuse is going to be whatever the legs are, x. X times the square root of 2 is the length of our hypotenuse. So that is 7 in our example. In order to solve for x here, this is x times the square root of 2. We're going to go ahead and divide by the square root of 2. Which would technically be done, except for we did learn before with radicals that we are never allowed to leave a radical in denominator. So that means that you're required to rationalize. So to rationalize, we'll multiply by the square root of 2 over the square root of 2. And we end up with 7 times the square root of 2 over 2. So that is going to be the length of our legs here. This leg is going to have the x. This length will have a length size will have a length of 7 times the square root of 2 over 2. And this leg will also be the same. 7 times the square root of 2 over 2. Okay. That was short, sweet, and to the point. A couple different examples.